In this video, I'm going to go over some prerequisite knowledge about operations with integers that you will need to be able to do in this class, and we will keep doing it until we improve at doing these operations without a calculator, especially in the first few weeks here. So just for a definition, integers can be represented this way as the negative whole numbers, the positive whole numbers, with the dot dot dots on both sides to show that this number pattern goes on forever in both directions. The positives and the negatives, including 0, and only whole numbers, so nothing in between the 1 and 2 or the 2 and 3 would be called an integer, just the whole numbers. So we need to be able to add and subtract, multiply and divide with integers accurately without a calculator. That's the hope. So when the signs are the same and you're adding together, this is the easiest operation to do. You just add the values together and keep the same sign. So if you have 3 negatives and you're adding 5 negatives, in the end you have 8 negatives. So you just keep the sign and add the quantities together. If you have 4 positives and 3 positives, you add them together. There are 7 altogether and you keep the positive sign. You can count on your fingers if you have to until you get better at doing these sorts of operations without a calculator. If you are having different signs and you're adding together, then it matters which one's bigger, because in this case you have 4 positives but 7 negatives. So because you have more negatives and you're adding them together, then in the end your answer should be negative. You have more negatives. You can think about it as 4 of the positives are canceled out by 4 of the negatives, and what you're left with is 3 negatives. Or you can follow the instructions here, which has to subtract the values and keep the sign of the bigger one. So if you subtract a 4 and a 7, you're going to get 3, and you keep the sign of the one that was bigger to begin with, which was the negative. So again, in my note here, it says you're adding 4 positives to 7 negatives. 1 positive and 1 negative basically cancel each other out to make a 0 pair. Since more are negative, your answer should be negative. You have 3 negatives left over. I have also seen people do a chart like this, where they might say, all right, I've got a positive and negative chart. With the number 4, that means I have 4 things over here. And with the number 7, that means I have 7 in this column. 1, 2, 3, 4, 5, 6, 7. And each positive and negative, one from each side, make a 0 pair and just cancel each other out. So each of these ends up getting canceled out to 0. And what you're left with is 3 in the negatives column. So it's another way to think common sensibly about how you add positive and negatives together. For practice, 7 plus 5, I gave it away, is 12, so you could always pause and practice these and then check your answers against what's in the video. Negative 4 and negative 8, we've got the same sign, so we're going to add the numbers together but keep the sign, so negative 12. In negative 17 and 9, we've got different signs, so I'm remembering I want to subtract the values to sort of cancel out all those 0 pairs. If I take 9 away from 17, I've got 8 left over, and they should be negative in the end, because there were more negatives to begin with. In the last example, I've got both negatives, so I'm going to add them together and keep the sign. More practice, we've got a positive and a negative. Again, I'm going to subtract the values, which gives me 7, keep the sign of the bigger one, which was positive 10. Another one, I've got 3 and negative 9. I'm going to subtract the values, keep the sign of the bigger one, which was the negative 9. An 11 and a negative 2. I'm going to subtract the values, keep the sign of the bigger one, which was the 11. And finally, negative 5 and 5, I'm going to subtract, I'm going to end up with a 0, and zeros are neither positive nor negative, so I don't need to put a sign in front at all. Then we get into subtraction. Subtraction problems should be converted to addition problems, because we've just learned the rules of addition, and subtraction just is addition. It's the addition of the opposite. So you can see subtraction and think add the opposite. Or you might have heard people call it keep, change, change. So you're going to keep the first number, you're going to change subtraction to addition, and then you have to change the sign of the number that comes after it to the opposite sign. So I changed, let me see how I can do this with colors. I'm going to change it to addition, and I'm going to flip the sign of the second number. Or, you know what, it's a little bit too crowded there. I'm going to rewrite it. You keep it, you change it, and you change the sign of the second number. So keep, change, change. Now I can follow the rule I just learned, which is when I'm adding together and I've got different signs, I subtract the values and I keep the sign of the bigger number. So 4. Of course, we know that 7 minus 3 is 4, like we didn't need to go through that whole process, but I wanted to show you that it is indeed possible to use the keep, change, change, and it'll work out right every time, which can really help when you have something complicated like the next 2 examples where you've got a lot of negatives and minuses floating around. You keep the first one, you change it to addition, and you change the sign of the second number. Keep, change, change. And then you've just got 6 plus 8, which is 14, both positive, keep it positive. In the last example here, keep, change, change gives us -5. Change it to addition, and then change the 11 to a positive. So keep, change, change. Now I've got one positive, one negative. I'm going to follow my rule, which told me subtract the values, keep the sign of the bigger number, which here is 11. So I end up with 6 positives. Again, you can pause and practice, and then check your answers against me here. 5 minus 6 is -1. I'm going to keep, change, change. This gives me a 9. I'm going to keep, change, change. This gives us a -7. Keep, change, change. This gives us a -19. Keep, change, change. This gives us a -12. And keep, change, change. This gives us a -13. Again, a whole bunch more examples, lots of negatives floating around. Practice your keep, change, change, because these are all subtraction. So I'm going to keep, change, change, gives me a -6. Keep, change, change, gives me a -5. 10 minus 3, right? When you notice you're just dealing with a simple subtraction problem, you can skip over the rule and just do what you know. Let's see, 6 minus -6, keep, change, change is actually a +12. 9 minus 9, I noticed right away that was a pretty simple one. I can just write 0. And then -8 minus 10, I'm going to do a keep, change, change, and I end up with -18. Adding and subtracting integers when you've got more than one in a row, I recommend that you add all the positives, add all the negatives, and then perform the final addition by doing a negative and a positive together. So add all the positives, separately add all the negatives. So what that would mean for this example is I've got a bunch of positives, 2, 3, and 5, gives me 10. And then I have a negative, and then I'm going to do one last simplifying step to get my final answer. In this example, I've got some negatives and I've got some positives. So I'm going to do the positives first. 5 and 7 makes 12. I've got some negatives, which I know means I can keep the sign, add them together. And then I'm going to do my final operation to simplify one last step. And then another example, I'm going to do my positives first. +5 and +6. I'm going to do my negatives next. I got a -7 and a -9. And then I'm going to do my, I see I have subtraction, keep, change, change rule. So it's going to be keep, change, change. I've got two different signs, so I subtract, keep the sign, the bigger number, and I get -5. So a bunch of shortcuts you can practice for doing these operations without a calculator. I'm going to skip over this slide for the interest of time and get to multiplying and dividing. So just looking at these examples that are done, see if you can generalize a rule from these correct answers. When I have +2 times +5, I get a +10. And when I have a -2 times -5, I also have a +10. So both of these ended up being positive. Then I see this example. I got a -2 times 5, and the answer is -10. In all of the rest of the examples, right, or the next few examples anyway, I have one that's positive, one that's negative, and I end up with an answer that is negative. One that's positive, one that's negative, and I end up with an answer that is negative. So these gave me positive answers, these gave me negative answers, and then here I have a negative divided by a negative, and I have a positive answer. So see if you can generalize the rule based on this. You might notice that when the signs are, as in the examples I'm about to circle, when the signs are both positive or both negative, you can see that your result is positive. When the signs are one of each, the original problem, you can see that the answer comes out negative. So when both are positive or both are negative, your answer is positive, and when you've got one of each sign, then your answer is negative. When there are more than two, it goes on this every other path. So if there's just one negative, you've got a negative answer. If there are two negatives, it's positive answer, right? If you've got 3 negatives, so now you've gone ahead and thrown another negative back in, it comes back to being negative again. If you keep going, you add another negative to the multiplication, you're going to get a positive again. So it depends on how many negatives you have. If you end up with an even number of negatives, your answer will be positive. And then we can learn by seeing examples. This is going to be your best bet. So you can go ahead and try these based on the notes you've taken, and then come back and check your answers. When we're multiplying 7 by 8, if they're both positive, our answer will be positive. Multiplying -4 times 5, because one is negative and the other is positive, the signs are different, then my answer is negative. Again, when the signs are different, your answer is negative. Signs are the same, so we've got a positive answer. Signs are different, so we've got a negative answer. Signs are the same. Here we've got 3 numbers being multiplied, but only one of them is negative, so we're going to have a negative answer. And then here we've got 3 numbers being multiplied together, but 2 of them are negative, which means we're going to end up with a positive answer in the end. And that is all.